Comunicate.
Okay.
Yes.
Yeah, thank you, sir. So, well, it is time constraint. We are starting live, sir.
That's fine. Not an issue.
A very good evening, all the dignitaries, the faculty members, and all my friends present in this meet. I'm K. Vinita. Firstly, I welcome you all to Teckzite' 21, the virtual saga of technovation, which ultimately provides you the marvel of virtuality. Every year Teckzite is one side, and this year Teckzite is other side. Despite this pandemic, our SDCSC is organizing this Teckzite, the national level Techno Management Fest, virtually for the first time ever. As a whole, there are 50 plus competitions, virtual tech exhibitions, project expo, and guest lectures. I'm even proud to say that our Teckzite team is contributing 20% for the medical advancements, which is much needed in these unusual situations. And today, it's a great pleasure for me to introduce our speaker, Dr. Sushil S Ramdasi, sir, who is Deputy Director at Automotive Research Association of India. This is an area which we should all be deeply interested because the automotive industry is a major industrial and economic force worldwide. Dr. Sushil S Ramdasi, sir, is in charge in Powertrain Design Department, ARAI, and responsible for execution of various projects in design and development of engines, transmissions, life axles from concept up to series producing for meeting various emission norms, strength, durability, and structural dynamics requirements. He did many research and achieved many achievements, and some of them are he has received an outstanding paper and presentation award at Visita International Conference 2018. He has received Best Technical Paper Award on Environmental Pollution at CEAT 2011. He was convener for 3 days global online technical conference at Fuel Cell Technology and many more achievements. He has presented and published more than 50 number of technical papers in national and international conferences. We are pleased to have you with us, sir, today to enlighten us more about the advanced future technologies with your thoughts. Thank you, sir. Now I hand over the lead to Dr. Sushil S Ramdasi, sir. Thank you.
Yeah. Thanks, Ms. Kavita, for a very nice introduction. And it's a pleasure to be on this platform for the first time. So welcome all audience and a very good evening to all. So actually, initially I was thinking to have a brief presentation, but since I come to know that it will be a live streaming, and because of then our some company policies and all that, and to respect it, it's better that I have decided that I should have some sort of only live interaction through a talk. So if anybody wants to have some thoughts in mind to be asked in the form of questions, I suggest they can send in a chat box to the organizers, okay? And then organizers can decide which questions they want to put for me for giving the answers. Will it be okay? Will it be fine for everyone?
Yes, sir, it is fine, sir. We'll do that.
That's fine. Okay. So before entering into the today's talk, I would like to give the brief introduction of my organization first. And after that, I would like to give the details about the profession where I am right now working, that is in the field of mobility engineering. So I will start talking a lot of advancements, trends, okay, technological challenges, opportunities in the area of mobility engineering first. Afterwards, I would like to talk you something on the new trends or the new horizons which are coming, like IoTs, then artificial intelligence, embedded systems, mechatronics, robotics, automation, high performance or high computing environment architectures. Then what are the opportunities in electrical and electronics and control engineering? Then lot of opportunities in the areas of instrumentation and building test rigs. Then we will touch upon slightly, not in depth, but we'll have some overview of opportunities in chemical engineering, then the specific domains in chemical engineering which are closely connected with the mobility engineering, which includes, for example, the refineries or the manufacturers who manufacture the technology for making different kind of fuels. So this is the overall, what I can say, the content for today's talk, and I would like to finish by 7 p.m. Before that, 10:15 p.m. I would like to finish, and then 10 15 minutes we can have a live session, live interaction with you. If you can raise your questions through the mode what I present, what I explained, it will be a great thing for me. So let's start now. Yes. So Automotive Research Association of India, ARAI, where I am working for last 3 decades. So in the introduction, you must have heard that I am working in a vertical named as a powertrain design. So Automotive Research Association of India, ARAI, is an autonomous organization formed by the government of India in the year 1966. And it is not only formed by the government of India, but it is supported well by the entire automotive fraternity and automotive industry. Then slowly we started functioning, and now almost we are more than 5 decades have a presence in India, and I'm proud to say that ARAI is one of the very trusted and branded and apex organization of India in the field of mobility engineering, for serving to the nation, for serving to all OEMs, that is original equipment manufacturers, and we offer the services in terms of research and development and homologation and certification. So this is the brief background of my organization where I work. Since I'm working for the last 3 decades, I thought that it's an appropriate, okay, I should start with this. Okay. Now, as I mentioned, there are 2 streams in this. One is the R&D, research and development vertical, and the second one is the certification and homologation. Okay. Now, I belongs from the R&D. Offer the services. So basically, and homologation and certification.
Hello, sir.
The brief background of my organization where I work. Since I'm working for the last 3 decades, yeah, some echo is coming. Some appropriate. Okay, I should start with this.
Hello, sir.
Yeah, shall I start? Some echo was coming. Am I audible? Hello.
Sir, you're audible, so you can continue.
Yes, sir. Yes, sir. Yes, sir.
Yeah.
Sorry for the interruption, sir. Please continue.
That's fine. So we have total 4 departments in the area of research and development and 10 different departments in the area of certification and homologation. And I belongs to
Hello,
the
sir.
area.
Hello, sir.
Yeah.
Yeah. Sorry for the interruption, sir. We are unable to see your video, sir.
You want? Okay. Am I audible?
Yes,
Is it
sir.
okay?
Now
Hello, sir.
your video is
Audible,
visible.
so you can continue.
Yes, sir. Yes, sir. Yes, sir.
Yeah.
Sorry for the interruption, so please start.
So as I mentioned, there are 4 different verticals for R&D and 10 different verticals for certification and homologation. I belongs from a vertical called as a powertrain design and mainly responsible for design and development of engines, transmission, axles, electric and hybrid electric and fuel cell electric vehicles. So this is the core domain for last, as I mentioned, so many years I'm working in that. Okay. So it's an appropriate now to start today's talk by taking you all through the complete journey of mobility engineering for last 2 decades. Why last 2 decades? There is a specific reason for it. That also I would like to mention during my talk. Okay. So let's start this journey from the year 2000. Okay. But before that, again, I would like to clarify one thing. I will start first with the mobility engineering, and then we will slowly touch upon different engineering aspects I already mentioned. Okay. So don't take it like that. I'm going to focus only on the mobility engineering. Okay. And this is going to set a context, okay, for today's discussion. And then slowly we'll keep on building and adding the things, and then you will get exposed, okay, lot of the opportunities, avenues, okay, what are the kind of resources, skill sets required in different engineering domains. Okay, that's the background. Okay. So in year 2000, Government of India adopted the emission legislations for all kind of on-highway and off-highway vehicles. We decided to adopt European emission legislations, and that's why in year 2000, we implemented with Euro 1 emission norms, and then we started calling it as a BS norms, BS1, BS2, BS3, BS4, and today in year 2021, we are now BS6. Before that, means before year 2000, there were no norms on emissions in India. So when those norms announced, then really a revolution started in this field. Rather, this revolution was there in Europe, in United States, and in Far East countries, much before than when it started in India. But making emission legislations compulsory has literally turned this industry into a totally different direction. So how it has impacted on different fronts? When I say different fronts, means technological front. That is the number one. Second one, on customer front. Okay, because when you are going to adopt technology, or when you want to enhance the present technology to meet certain legislative requirements, to meet certain safety requirements, to meet certain durability requirements, to meet certain fuel economy or noise and vibration requirements, because we're talking about the mobility. That's why these are the performance parameters. So it is having all impact on customer. It will have impact on the customer, not only from economics point of view, but from his perception point of view, his comfort point of view, his affordability point of view. Okay, so many aspects are associated with any change if happens in the technology, and exactly that started happening from year 2000. So I want to give one small example, which is what I can say a little bit technical, but I think it's an appropriate. And then suddenly at 2016, the government of India decided to leapfrog from BS4 to BS6. So they decided that we should not go to implement BS5 emission norms, and it was a big change. Okay, and as I mentioned, that in this journey, detailed engine specifications. I will not go into the details of mechanical engineering and automotive engineering, because I know that there are a lot of other viewers and listeners, they are from many other engineering disciplines. Okay, so what are those technical changes? That is not, I think, the lecture is supposed to be. But thing is that a revolutionary change has happened. Okay, and the whatever 120 years back, today it is the same, but it has been highly optimized, compact, downsized. Its specific power, specific torque increased, and a very good thing has happened, that a very good fuel consumption with a minimum emissions. So BS6 emissions, when we say emissions, it incorporates CO, HC, NOx, particulate, and CO2 emissions. All these 5 emissions, if you compare before 2000 and if you compare in year 2021, okay, practically there is a huge, what I can say, almost more than 70 to 80% reduction has happened. The jump from BS4 to BS6 itself was around 40%, 40 to 60% reduction. Okay. So what has happened because of this? The cost of the technology, the cost of the product. You know, the engines which were there complying Euro 4 or BS4, and the engines which are there today, BS6, meeting Euro 6 or BS6, there is a difference of 25%, okay, rise in capex. I think you are aware of this concepts, capex and opex. So the 25% rise in the capex if that engine is Euro 6 compliant. So ultimately, where the OEMs are going to transfer this load, obviously to the end customer. And that is the reason the vehicle prices have been shoot up by 20 to 25% if you want to buy a BS6 vehicle over a BS4 vehicle. That's fine. Because now it is mandatory. You have to pay for the technology because it is for the environment. Okay, it's not only for the environment, but it is from the fuel consumption point of view. But in spite of that, in spite of doing all this jugglery, okay, still 2 major challenges remain unanswered. What are the challenges? Okay, one challenge is the CO2 emissions, or in other words, we call it as a greenhouse gas effect. CO2 is called as a greenhouse gas effect. What is the meaning of this? CO2 is mainly responsible for 2 reasons. One, global warming effect. Okay, and the second one is the ozone layer depletion. Okay, and the mobility industry is one of the major contributor for this CO2 emissions. Okay, and that is the reason, apart from CO2, other emissions were like CO, NOx, particulate. Okay, they are also having a lot of harmful effects on human health, and that is the reason across the globe, okay, the government started the emission legislations. Okay, so other emissions now we have substantially reduced, but still CO2 emissions is a question mark. You might be knowing that in year 2016 at Paris, okay, different nations, they signed an agreement. It is called as Paris Agreement. That agreement was towards for your efforts in controlling or implementing measures to reduce the global temperature by 1.5 to 2 degrees centigrade. So all those nations who have signed this agreement, they are committed that they should implement those technologies in different sectors which are responsible for CO2 emissions. So mobility is one of the major sector for CO2 contribution. It's not the sole contributor. There are so many. Industrial, power generation, there are so many. Okay, but CO2 contribution from the mobility sector is a substantial. Yes. So yes, when we started from Euro 1 to Euro 6 today, there is a certain reduction in CO2. But now in order to meet this 1.5 to 2 degrees centigrade reduction globally, it calls for certain further reduction in CO2. Right now with this technology, the CO2 is coming roughly around 140 grams per kilometer. Okay. Now in order to reach to the Paris Agreement target, that CO2 should be in the range of 50 grams per kilometer or less than 50 or even 0. And that is not possible with the present IC engine based gasoline or diesel, or even with whatever alternate fuel technology you are talking, like ethanol, methanol, CNG, LPG. So many fuel options are available. This is not possible. Reason is that IC engine's efficiency is now practically reached to its saturation limit. 20 years back, the diesel engine's efficiency were of the order of 31-32%, and now practically they have touched to 38%, 40%. Maximum it can be extended to 42%, 43%, but not more than that, because it's having its own limitations. The technology is having. So practically we have reached to a saturation limit of IC engine. IC means IC engine technology. Then how to meet this target? Okay, and that's why now there is a change required, okay, in the technology. There is no need of upgrading the present technology. So we don't need now upgradation of existing technology. That we have done for last 120 years. Now what is required? We have to think something different. We have to completely change the concept, completely change the powertrain technology. And that has emerged a buzzword called as e-mobility. You got my point? So this is how we are now in a big transformation state across globally, from conventional powertrain to the e-powertrains. Okay? So this is called as a major disruption that's happening into the mobility sector. Yeah. Just give me 2 minutes. Okay? Sorry for that. Yeah. So that is the basic major disruption what has happened from conventional powertrain to this. So you might be knowing that 3 years back, the government of India announced a major step towards this. What was that? That by 2030, year 2030, all vehicles should be electric vehicles. Okay? No ICE vehicles will be on the road. And then what happened? It has created a big chaos. A lot of rebels from OEMs as well as from all tier 1 suppliers. Why? Reason is that I have already again mentioned, this technology is there 100 plus years. So a lot of supply chain and ecosystem is in existence for so many years. Okay? It's a traditional industry, traditional mechanical industry. So automotive industry is basically a part of mechanical industry. So what are the different sectors involved in this mechanical industry or automotive industry? So we can divide it into different sectors, okay, such as casting industry, forging industry, machining industry, sheet metal industry. Okay. Then, as I mentioned, IC engine uses a lot of fuel injection equipment. The companies like Bosch, Delphi, okay, Standard Iron. Okay. Then ICE uses a lot of after treatment devices, diesel oxidation catalyst, particulate matter, lean NOx, okay, silicon, selective catalytic reduction, urea injection. So there are companies, dedicated companies, who are developing this product for so many years, okay, and they are part of this complete ecosystem, supply chain, and the entire revolution what has happened in last 20-25 years. Okay. And suppose suddenly if you tell tomorrow that we don't want to use this conventional ICE technology, okay, and in the next 10 years, everything will be the electric vehicle. Is this 10 to 12 years time is sufficient to absorb this jolt, to absorb this disruption? No. And that was the major reason all OEMs and tier suppliers, okay, they were reluctant, okay, to have or to adopt this sudden change. And that is the reason, after a lot of consultations, meetings, panel discussions, okay, it has been decided that by year 2030, we should not make it mandatory for 100% electrification, but at least 30% of the total fleet, we should make an attempt to make it electrified. Earlier it was mandate, now it's an attempt. And I think that's a fair thing, good thing. Okay. But still, we decided to go with the electric vehicles. Okay. So, generally, when any government takes such kind of decisions, they generally follow certain roadmaps which are already implemented somewhere. Okay. So, government of India followed the roadmap of China. Okay. Because you know that in China has already adopted the policy to go for 100% electrification, and I think mostly they are successful in it. But there are some different reasons why China is successful in that. But I think we have not gone into those details why China has become successful in this, and we directly decided to go for that. No doubt, objective, mission, absolutely fine. But some other parameters need to be considered and has to be thought before implementing such kind of disruptive thoughts. Okay, disruptive actions, rather, I will say. China is having abundant amount of control on lithium ion. I said, very important word, control. There is a misconception that there is a lot of lithium ion is available in China. Yes, it is available. But major lithium ion, which is a major constituent in the battery, lithium ion battery, is available in South America and in African continent, mostly in South America. Okay, like Chile and all those areas. And all those mines, lithium ion mines, they are under control of the China. Okay, and that is the reason they have got abundant availability of the material which is required for a battery, and that is mainly for the electric vehicles. And that is the reason they promoted it and they become very successful in that. No doubt about it. Yes. But we have not given thought of that. See what will happen. Suppose India decided to go with 100% electrification. So many vehicles are flying. All these vehicles will require lithium ion batteries for the time being, because that is the right technology available at this time. From where so much lithium ion will come? Okay. Right now, we are depending for fuel on Gulf countries. Now we will shift our focus from Gulf countries to other countries, and the control is with China or some other countries like similar to China, which are owing this all controls on the lithium ion. So whether the problem which is related import of the crude oil and the cost associated with it, we are shifting from one point A to point B. Okay, and that's why still we think that the roadmap what we have followed of the China, yes, theoretically it's very good. Practically, still there are big question marks. Then which roadmap we should have followed? We should have followed the roadmap of Japan and South Korea and some of the European countries. What the roadmap they are following? So they are following the roadmap of hybrid electric vehicles. Okay, so I will explain it that. I already mentioned we have entered into that era where we don't want to upgrade the technology, but we want to change the technology. And the change in technology in the form of electrification, which has become the buzzword. But when I say electrification comes in three ways. One, pure electric vehicle. Second, hybrid electric vehicle. And third one, fuel cell electric vehicles. Okay, so these are three different segments. So which we should start? That was actually, it should have given a proper thought, rational thought, but it has not happened, unfortunately. Now, what is hybrid electric vehicle? So everybody is aware of Toyota Prius, okay, which is an iconic vehicle in the market. And Toyota launched it in year 1998. See the vision. Okay, in the year 1998, okay, the commercial available Toyota Prius, okay, launched. And yes, the kind of engineering and the kind of technology they used, okay, they got huge success in this. So what exactly a hybrid electric vehicle does? It has two power plants. One is ICE and second one is the electric motor, which is operated by the battery. So you have one ICE engine, which requires fuel. And the second one is the electric motor, which requires a battery. Now, there is more element or system. I will not use the word element. It's a system, and that system comes in the form of a complex transmission, where it either allows engine to be operated alone, motor to be operated alone, or motor and engine to be operated together. That is called as a hybrid mode. And it offers in such a way that always whatever torque is demanded by the vehicle, it should be met optimally. When I say optimally means both power plants should run in the most efficient zone. Okay, that is the main sole purpose of the hybrid electric vehicle. So if you have around 50 kilowatts IC engine, then you can have around 35 kilowatt of electric motor on board, or maybe of same power rating of IC engine. It is called as a strong hybrid electric vehicle. And in this category, strong hybrid electric vehicle, what I mentioned, the different modes of operation, pure engine, pure motor, or hybrid mode, okay, or even motor acts as a generator, engine drives the motor in generator mode and charges the battery, and during that, engine offers a power to the wheels. It's a very complex architecture, but it gives fuel economy improvement over base more than 30%, 35%. Don't you think it's a very huge figure? Per vehicle, saving in fuel by 30%, 35%. Very huge. Okay. So that is directly going to reduce your fuel consumption, and CO2 emissions are directly linked with the fuel consumption. So if you reduce the fuel at source because of the electrification, that much percentage of CO2 is going to reduce. And that is the step towards the electrification. So while doing this, what happens? You are giving life to the IC engines. So IC engines, still they will continue with some more research in improving their efficiency. Plus, you are giving time for increasing the penetration of electric drive components with motor, battery, BMS, power electronics, so many other things. Right now, the cost of this technology is very high because there is no volume. But with hybrid electric vehicles, this technology will start slowly penetrating. You will get certain time. In that time, what will happen? Volume will keep on increasing. Even that technology will get more time to become more mature. IC engines will get continued. So what are the stakeholders are there in the present ecosystem, supply chain system? They should not worry about it because they are having some time available with them. And since volume increased, the cost of the battery and all other electric drive system components will go down. So it will become affordable. And that time, okay, you can think of shifting towards the pure electric vehicle. Okay, and that is the exact roadmap is followed by Japan, South Korea, and some of the European countries. I have not taken the name of the United States because they are having still abundant amount of fossil fuel with them. But now, as on date today, lot of emphasis is given on electric vehicles and fuel cell electric vehicles, and a lot of movement is started in that direction. And the credit goes mainly to Tesla, that everybody is aware of it. Okay. So this is the, what I can say, the roadmap we should have followed, and then go to the pure electric vehicle. So you will transform from the conventional powertrain to the EV through the hybrid route. That's fine. Then what will happen to the present stakeholders in this ecosystem? Now, slowly the percentage of IC engine will go down. The statistics and the data available, which we have consolidated from various international meetings, forums, conferences, and roadmaps, says that by year 2050, almost 98% of the vehicles will be electrified. Mostly, major percentage will be in the form of EVs or fuel cell electric vehicles, and followed by third will be the hybrid electric vehicles. And those hybrid electric vehicles will be also called as a plug-in hybrid electric vehicles, where they will have very large battery which can be charged through the external grid. So that dependency on IC engine will be very, very less. Okay. So practically IC engine's existence will come to the end by 2050. We are today in year 2021, so we should not worry. Practically 30 years are there, okay, for the ICE technology and associated supply and ecosystem. That's fine. But still, this transformation has to begin. So when we are converting or changing from conventional powertrain to the EVs, hybrids, or fuel cell, the areas the areas which I'm going to mention, okay, we have to pay a lot of attention in terms of what? Research and development, in terms of indigenization, okay, in terms of making prototypes, in terms of creating infrastructure, okay, for manufacturing or producing this technology on mass scale, on series production. Okay, so which are those areas which are going to take, okay, or which are going to supersede the conventional powertrain? Number one candidate is the electric motor. Okay, then battery, then power electronics, then motor control algorithms, then battery management system, BMS system, then other power electronics components like DC-DC converter. There are a lot of contact breakers, circuit breakers, so many things. Okay, so if there are any students from electrical or electronics engineering, they can understand this. All these areas will start picking up like anything. Rather, it has started already. The movement has already started. Okay, so the people who are in conventional casting technology, now they should start focusing on how they can enter or tap into this new business opportunities. For example, electric vehicle also needs a cooling system to cool down electric motor as well as the battery. So the components which are used in electric vehicle cooling system, for example, they are same to that of the powertrain, conventional powertrain, with water pump, then radiator. Okay, so the present stakeholders, they should start thinking in that direction, that whatever products I am developing today, maybe from the perspective of ICE, can we slowly started expanding our horizon, okay, for a new product development. It may be a diversification from the existing line, or it may be a totally new product for them which they are not producing. Of course, it will require certain kind of investments, capex investments. Okay. Now, I will not touch upon more on that capex, opex, and startup kind of things, but the time has come, okay, to focus on those aspects, and then how we can become sustainable in long terms. Okay, But to become a sustainable, is it the sole responsibility of the present stakeholders? No. For that, the technology has to become sustainable. If the technology becomes sustainable, then the businesses associated with this technology will become sustainable. And once they become sustainable, volume will increase, then it will become affordable. You got my point? So this is some sort of a vicious circle, affordability and sustainability. Okay? Because to become affordable, there has to be volumes. And to have that volumes, the cost should be lower. And to have that cost lowers, the business should be sustainable, product should be sustainable for a certain period of time. There has to be acceptability from the consumer. Okay, because ultimately it has to be accepted by the end consumer, end customer. And exactly that's what not happening today. And that is the reason still there is only sound or noise of e-mobility. But in reality, the implementation is very, very less. Okay, and this is where the main problem is. You got my point? So here, we have to identify why this is happening. This is mainly happening purely because of customers' perceptions, customers' preferences, and there are some mind block sets related to this technology. Okay, so we have to overcome these mindsets, block sets, okay, of the end customer. We have to change its perception. But who is going to do that? Are the only OEMs and tier 1 suppliers who are this technology producer, are they going to do it? No. It is a teamwork. It has to be done. Rather, it's a top to bottom approach. It has to be initiated by the policymakers. It has to be initiated by the government in the form of making policies, rules, regulations. Only is it that responsibility? No. While making that, they have to ensure, okay, sufficient kind of infrastructure, sufficient kind of funds, so that with that funds, the technology will be developed on proof of concept basis, will be demonstrated. Lot of demo programs has to be there. And those demo programs should not be only on paper to write a thesis or journal paper, okay, for getting PhD or getting for citations. Okay, it has to be on real world, practical world. Those projects should be demonstrated and should be allowed to run in the market so that people can see it, people can feel it, people can get experience of it. So getting experience or giving experience to the consumer and customer, that is the main key right now to overcome all these challenges. And to give this experience, feel of the technology, it's not the only responsibility of OEM, tier 1 or academicians or R&D organizations. It is a joint responsibility along with the policymakers or our government. It's very, very important for that. So for that, we have to identify those areas. I think already a lot of work has been happened in this. People have already identified. The people are approaching to the government, and fortunately, the government is pumping a lot of money, especially in the area of not only e-mobility, but in the area of even the conventional fossil fuels. I think in the last week, you must have read the news where the Honorable Prime Minister launched E20 mission. You know that? Now, the use of 20% ethanol in fuel, that deadline, it has been extended. Earlier it was in, I think, year 2028 or 30. Now it has been preponed by 2025. What will happen because of that? Whatever crude oil we are importing, out of that straightway 20%, there will be reduction in the crude oil import, because that ethanol we are going to produce in India through bio-waste. Okay, see how different variables are linked with each other. Different technologies are linked with each other. And ultimately, all those things lead to a global eco chain or ecosystem. So this is the best example what has happened in the last week, that our crude oil import is going to reduced by practically 20 to 30%. What my point? So this is the initiative by the government, and now government has mandated it through regulation, rules. But at the same time, they did a lot of homework. Yes, still the homework is not, I can say it's a foolproof. But yes, they gave sufficient time. They discussed with all refineries. They discussed with so many technology companies who are in the business of making fuels. Okay, there are companies like you might be knowing in Pune, a very popular company called as Praj Industries. Okay, they are in the business of, you must have heard so many times, or read rather, in the newspapers. They have got so many, what I can say, the lot of awards of the projects and all that in the area of biofuels. What they do? They make machinery for producing the fuel. They are not fuel manufacturers. Okay, so they are the pioneer in India to have this technology, which can be used by refineries or somebody else. That's a different thing. You got my point? So the government of India had several meetings with such kind of people, refineries and all that, even with all farmers and all that, sugarcane industry, so many. And once they got the confidence that sufficient amount of biomass will be available to produce the ethanol. And that's why here government of India followed the roadmap of Brazil. You might be knowing that Brazil is having abundant amount of ethanol production. Okay, for so many years, there are 100% ethanol fueled vehicles. Now the trend is changed. Instead of using ethanol in the IC engine, they are using now ethanol into the fuel cell electric vehicles. So the ethanol will not be combust, but electricity will be generated out of it. Okay, so that is the major sea change happening in Brazil. Okay, but some part of that roadmap we adopted. You got my point? But while adopting this roadmap, yes, there was a proper homework. Okay, and it has been implemented. So this is the example where all stakeholders from different categories of different levels, they have come together, demonstrated the technology, implemented the technology, and the tangible benefits has been demonstrated. Straightway 20% reduction. I think today in the newspaper that amount has also come, that per year how much US dollar we are going to save. I think it's a great move. Okay, so it has boosted not only the reduction, what I can say, it has not resulted only in reduction of the dollar what we are spending, but it has boosted the farming sector also. Correct? It has boosted to the fuel technology manufacturers also. Okay, so such kind of decisions helps in creating sustainable and affordable businesses. Got my point? And this is how the balance between economics, environment, and social needs has to be matched. And while matching this with the use of technology, you are creating sustainable, viable, and economical eco chain or supply chain, which is beneficial to all. That approach not only has to be followed in this sector, this is just example I have given since I belongs from mobility sector. It is always possible to use such kind of examples in different engineering disciplines. So I will touch upon that. So we talked about conventional powertrain. We talked about hybrid electric vehicles. We talked about biofuel. For example, ethanol. There are so many other biofuels, but this is not the time to discuss all those biofuels. So the last topic from mobility sector, which I'm going to discuss, is about the fuel cell electric vehicle. What is that? Okay. Basically, fuel cell electric vehicle is the electric vehicle itself. Okay. So what will happen? See, if you want to have all intercity buses and the trucks which are flying between city A to city B, if you convert it into the electric, that's fine. Technologically, it's possible. But you know, to travel between city A to city B, practically, let's assume that 300 kilometer plus 500 kilometer, maybe 800 kilometer, they have to travel. So can you imagine what amount of battery energy density required to be on board? How much big size battery is required? It's practically impossible to have that much battery. So like petrol pumps, they need something, and that is nothing but a charging infrastructure. That means after traveling 300 kilometers, they have to halt and they have to charge such a big energy density battery, minimum 4 hours, even if they go with a fast charging option. Now, suppose it is an intercity bus, what the passengers will do for 4 hours? Okay. To overcome this, the fuel cell technology has come into the picture. It has come to the rescue of electric vehicles. What is that? Fuel cell is a device. See, this is the application of chemical engineering. A very important statement I am going to make at the end of this mobility section. Before that, please listen to this. It's an application of chemical engineering. But it is only chemical engineering? No. It's mechanical and chemical engineering because it involves thermoelectricity. There is a thermodynamics also involved and chemistry also involved. Very, very important. What is that fuel cell? Very simple, but at the same time very expensive. It is similar to battery. It is having anode, it is having cathode, it is having electrolyte. But that electrolyte is in the form of a polymer membrane. Okay? It's a thin film of polymer. And on its left and right hand side, there is a catalyst layer. And that catalyst layer is of platinum. Underline platinum. Okay? Now what happens? You supply hydrogen on one side. When the hydrogen will come in contact with platinum, you know hydrogen is having one proton, one electron, one neutron. There is a catalyst. You require some temperature, 80 degrees centigrade or 100 degrees centigrade. At that temperature, when the catalyst will come in contact with hydrogen, it will remove the electron from its orbit. And that then electron is released as a electricity to the load. Then what will happen? H atom will get converted into ion. Because hydrogen is having one proton, one neutron, one electron. You have removed one electron. So only one proton. Proton is positive. So it becomes ion, H+. Now that H+ ion will transfer from anode to the electrolyte. And from electrolyte, which is a thin film of polymer, it will come to the other side where it will find again a platinum catalyst. Okay. Then at that cathode you are supplying air. So it will take oxygen. So that H+ ion, which has come to cathode, it will find oxygen from air. And it will also find the electron coming from the load, because ultimately that electron has to travel from anode to cathode. Okay, suppose let's assume there is a lamp between anode and cathode. When that electron will travel, it will illuminate that lamp. After that, it will come to the cathode. So at cathode, you have electron, H+ ions, and oxygen. It will form a water. Okay. It sounds very simple, but the most expensive technology in the mobility sector. Reason? Platinum as a catalyst and The membrane, what I mentioned, polymer, it's having a typical property. It allows only H plus ions to be transferred to the cathode. It won't allow electrons to be transferred. It won't allow hydrogen to be transferred. And that's the reason it's a very, very expensive. This material is called as a Nephyon, which is patented by a DuPont, which is a company in Delaware at United States. Okay. See the penetration of the product. Okay. Importance of IP protection. Okay. Right now, whenever you talk about fuel cells, especially proton exchange membrane fuel cells, hydrogen based, only 90% of the time you will listen the word DuPont, Nephyon membrane. You got my point? This is the importance of research in the field of engineering. Research is always there in different fields, like in medical sciences, space sciences, so many. This is the best example, okay, of the intellectual property based application. That is the reason the cost of this technology is very high. So this fuel cell, if you have on board of the vehicle, apart from a battery, but you have to carry hydrogen in tank. So it produces electricity, and that electricity is used to propel the wheels. It will be given to the motor. And during only acceleration conditions, battery will come into the picture. So the size of the battery will be very, very less as compared to the pure electric vehicle. Number one. And secondly, there is no need of charging infrastructure because you're already having hydrogen on board. Okay. Then somebody will ask the question, that's everything is fine, but where is the hydrogen? Okay, then it's a good question. Few years back, yes, this question was really a question. But nowadays, there is an answer for this question. Reason is that almost all refineries now having abundant amount of hydrogen available with them. That is number one. Second one, because of this government's push on biomass, whatever biomass is generated, bio-waste, biomass, there is a possibility to produce hydrogen by reformation technique of this biomass or biogas or bio-CNG to produce hydrogen. And there are a lot of companies now are coming to India to produce this hydrogen through these different technologies. And like a petrol pump, you will get hydrogen infrastructure available. It will take time. It's not going to happen in 2 years, 3 years time down the line. It will take minimum 10 to 15 years. Okay, but that is the next future. That is for sure. Is it clear? So, with this, the problem associated with the large battery charging infrastructure, especially in the heavy commercial vehicle segment, it is going to get resolved. Then fuel cell will find huge potential market in power generation application. There is no need of them having diesel generators. Use fuel cell, generate electricity. And wherever this fuel cell generator is placed, there itself, you just bring bio-CNG pipeline or CNG pipeline. There is a mechanism to produce hydrogen from this bio-CNG through reformation technique on site. So wherever is the generator, it should go along with the hydrogen generator also as a total unit. Okay. Then no emissions. Fuel cell only produces water vapor, zero emissions. You got my point? So this is how the sea change is going to happen in power generation application. When I say power generation application, mainly 3-4 areas I'm talking about. You require abundant power for data centers. Now, everything is virtual. Okay, in pandemic, the total, what I can say, the equations have been changed now. Today I'm talking to you virtually only. Okay, so ultimately, the IT industry, okay, has gone again through a major revolution in this last 2 to 3 years. Okay, ultimately, what is this? It's a data. So many your WebEx, then Zoom, everything. Almost all things are now on the internet. What is that? It's a data. Okay. Gigabyte, terabyte data is generated. It needs to be stored. It needs to be processed, and it is handled by a data centers. And that data centers requires a continuous power. Okay. So fuel cell finds a big application in data centers. Just to share with you, all this Microsoft, Amazon, Google, okay, majority of these giants in United States, they are backed up with Bloom Energy solid oxide based fuel cells. It is a different type of technology. It doesn't use hydrogen, it uses CNG, but there is an onboard reformer which creates hydrogen, and then hydrogen is used. So there is no need to have a hydrogen generator. Okay, so this is not the forum to discuss the difference between proton action membrane and SOFC. SOFC finds more place in power generation because of its own advantages, but it will not find major place in mobility sector. So you can see that the fuel cell technology will be widely used in mobility sector as well as in the power generation sector. So this is another opportunity, okay, in a power generation sector, okay, because fuel cell produces a DC voltage. Now that DC voltage need to be boosted through a DC-DC converter, okay, and then it has to be given to the load, okay. There will be power distribution in it. The load, before going to the load, you have to convert that DC supply into the AC. So there will be a 3-phase DC to AC inverter. So again, huge opportunities. It is already there with conventional power generation technology. All these systems are there, but now they need to be married. You have to do marriage of that systems with the fuel cells. So accordingly, you have to control the ripples in fuel cell output. Okay. Then you have to control the total harmonic distortion output in the inverter. You got my point. So this is how I think we have touched now the transformation from conventional powertrain to the very advanced powertrain in the form of e-mobility. We have touched diesel gasoline powertrains. We touched upon pure electric vehicles. We touched upon hybrid electric vehicles. We have touched upon the fuel cells, and we have seen two different applications of the fuel cell, mobility as well as the power generation. So practically, we have touched the complete, what I can say, the spectrum of mobility sector, and we have touched upon the power generation sector. Okay. Now I mentioned a few minutes back, I'm going to make a statement which is very, very important. Present conventional mobility is an excellent example, and it's a gift of science to the humankind. It's an example of a mechanical engineering. Automobile engineering is a mechanical engineering. Okay, it's really gift of science. Like computers is a gift of science. It has not happened in one day. It has also taken when Charles Babbage invented his first machine. I think almost more than 150 years. Okay, and then finally in 1956, when I think Bell Lab, there was a revolution taken place in the form of development of transistor. Okay, so I think these are major disruptions like invention of IC engines and invention of a transistor. Okay, so these are the best two examples of a science, okay, of which we are reaping the fruits. And much before that, I think the greatest invention is the electricity. Okay, that's fine. Now what statement I'm going to make? Now, the person who is working in this conventional powertrain, mechanical engineer. Okay, and now we have talked about the fuel cell electric vehicles. Is it fit then in that industry? Right now, if we say that I have the skill sets, knowledge related to only those products which belongs to the mechanical engineering. IC engine, for example, compressors, air conditioning system, refrigeration, chillers. Okay, these are some of the major applications. Boilers, yes, huge applications. It's a basic engineering, core engineering. Your computer engineering. So you require now a multi-engineering disciplines if you want to really survive in this competitive world. There are people, there are students who are having such kind of extraordinary skill sets, multidisciplinary. Especially the today generation, I found these skills. Okay, only thing, the depth of knowledge they have to increase. They know everything, but the depth of that has to be increased. In earlier days, there was a saying, jack of all, master of none. But now, that saying is modified few years back. Jack of all, but at least master of one or master of two. And now that saying really needs to be modified, that master of all. If really you want to contribute to the society with a quality, that's very, very important. I know that it's not possible to master in all disciplines, but he should at least master in one discipline and should have at least some 20%, 10% peripheral, I will not say peripheral knowledge, some knowledge. Okay, so that he can properly bring it into as a bundle, and then he can offer the services to his employer or wherever he is. Okay, so to have this change from conventional to this multidisciplinary, it's not a one-day process. You got my point? It's not at all a one-day process. It is a time-dependent process, and there are so many again stakeholders involved. It should start from research and academia level. Very, very important. Academicians has to take this responsibility. They have to change their system, curriculums. Okay, the practical exposure, project-based learning. There has to be inculcate into the students. Okay, and then once such kind of culture the students will get from the beginning itself, okay, then they will not face challenge when they will come to the industry, because they are already aware how to work in multidisciplinary engineering domain, how to do multitasking. You got my point? Then only they can offer a very good service for a product development. It's not always a product development. If they are in IT, they might be in the service industry also. It happens to all sectors. So again, under mobility engineering, we have touched upon different other engineering disciplines. See, nowadays, vehicle is not a vehicle. Its job is not only to take the good or to carry the passengers. You know, practically around 50 microcontrollers are running in a vehicle. Vehicle has to do so many jobs apart from driving and all that. You might be knowing all those things. Okay, it has own GPS system. It has own infotainment system. It has got so many safety features. Now, advanced concepts such as autonomous vehicles, driverless cars, then connected vehicles. Okay, advanced driver assistance systems. For example, lane departure warning, parking assistance, all these things electronically has to be done. So this is how I think the change everybody has to adopt, okay, from a very ground level. And then I think we can offer a very good, what I can say, we ourselves act as a very good usable product to the industry. So I think immense opportunities are again available in autonomous vehicle, advanced driver assistance systems, and even vehicle uses IoT techniques. There are so many examples. For example, if the person wants to locate a parking slot, IoT helps. This is the best example. And the fourth one, I said the connected vehicles from safety point of view. So is it only mobility engineering we talk? No, it uses artificial intelligence. It uses huge amount of sensor technology like radar, LIDAR, GPS based, telemetry, so many microcontrollers, so many actuators. Practically all engineering disciplines have come into this. Okay. So practically the code having in the aeroplane, just give me 2 minutes. Yeah, just give me 2 minutes. So you can see that practically whatever the complexities are there, okay, in the aerospace or even space, now they have come now into the automotive industry. And that is the reason I thought that to start with the mobility engineering, but happy to answer that. Thank you very much.
Thank you, sir. Thank you so much. On behalf of Team Teckzite, I extend my heartfelt thanks to you, sir, for giving such a wonderful lecture and giving us insights into the world of advanced technology and automotive world. I thank all the faculty and students who joined here and hope you all have enjoyed this session. Last but not the least, I thank the whole student organizing team for your hard work at the back end. Thank you, everyone. Good night. Thank you, sir.
Yeah, good night. Thank you very much. Thanks to all participants for their patience. Thank you.
Thank you, sir.
Yeah, thank you.
We should have one day session, sir.